So in this question we're looking at a hypothesis test for a proportion. We're looking at two different samples of cars, 500 each, and we find different numbers of vehicles that had some breakdown for either domestically or imported cars. So we're interested in the true proportion of faulty cars or of breakdowns in the two populations, domestic and imported cars, and we're interested in whether that true proportion is equal to 0.35. The information, as we do this test, we're going through all the necessary steps of hypothesis tests. So for 4.1 that's the domestic one, and 4.2 the imported car. Now we know that the first step is to set our hypothesis. So for both cases we need a null and alternative hypothesis. But perhaps before we continue, it's best to note down the pieces of information we have. We have two samples for each of the two groups, and they are both of size 500. They wouldn't need to be the same, but they are in this question. And what we are after is the true proportion, which I call that pi, which is of course unknown, but we have sample proportions. In the domestic sample, that's the one with subscript 1, it's 159 out of 500. So the proportion of faulty cars here is 31.8%. In the imported car sample, the proportion of cars with breakdown is 1:1 over 500. That's 24.2%. So let's continue with the hypothesis. For the domestic car, we have a lower one-sided alternative, so the null is that pi1 is equal to 35%, and the alternative that pi1 is smaller than 35%. For the imported car category, we have the same null hypothesis, but now we have a two-sided alternative, therefore it is that pi2 is unequal to 0.35. So next step is to set a significance level. None was actually given here, so let's say we set a significance level of 1%. So here we set it ourselves. That's what you need to do if there's no information given. Next we need to specify the test statistic. That's going to be a t-test when we're testing for proportions. And the test statistic is the sample proportion minus the hypothesized proportion. So that's the one from the null hypothesis divided by the standard error of P1. And you just need to know in this formula that's pi1 times 1 minus pi1 divided by n, where the pi1 is again the one we use from the null hypothesis. And that what that is, that's SP1, the standard deviation for P1. Now the same for the test on the imported vehicles. We have exactly the same test statistic, just with pi2. So what's the distribution of these? Well, the distribution of the t-test here is what we call asymptotically normal. So it's normal that t-test is normally distributed under certain conditions, which without any details here basically require that the sample size is large enough. So next, the decision rule, and we can use the easy one, reject H0 if the p-value is smaller than alpha. That's going to be exactly the same if we use two-tailed or one-tailed tests. Or, of course, if we use decision rules with critical values, they'll be slightly different. But let's just stick to the p-value rules. The decision rule is the easy bit. So let's do the calculations. We just plug in all the values we have. 0.318 for P1 and 0.35 for pi1, the hypothesized value, and then everything falls in place, and the value of that test statistic is negative 1.502 for the imported cars. For question 4.2, we have slightly different sample proportion P2. Pi2 is exactly the same, so that will mirror question 4.1, but the test statistic here is negative 5.0632. So with these test statistics under our belt, we've only written down one decision rule, the one involving p-values, so that means we need to calculate p-values. So again, it's easiest to clarify what we need using a critical value. We're having a left tail test. Our test statistic is negative 1.5, so we are interested in the size of that yellow area. That's going to be the p-value of the test, so we need to find negative 1.5, 0, so 0.0668. That's the size of the area to the left. So we just got this from the standard normal table because our test statistic is standard normally distributed, assuming our n is large enough. So what about the two-tailed test? Here our test statistic is negative 5.06. Again, we need the size of that area to the left. And what we require as a p-value for this two-tailed test is 2 times the size of this area. So basically mirrored on the right-hand side as well, but we'll just say 2 times because it's symmetric distribution. Now negative 5 is really off the scale. So really the size of this is virtually 0. Therefore the p-value is going to be 2 times 0, that is still 0. Now that is sufficient information to go back to our decision rule and make a decision. The decision rule was reject H0 if the p-value is smaller than alpha. Now on the left hand side for the domestic cars, the p-value isn't smaller than alpha of 0.01. That's the one we set ourselves, so we cannot reject H0, and the hypothesis that pi1 is 35% is okay. However, for the imported cars, the p-value of basically 0 is clearly smaller than 0.01, so we reject H0. So we come to the conclusion that pi2 is not equal to 0.35.